Right. Okay. Question. So in the diagram, PQRS is a rectangle. You know what is a rectangle, right? The properties of a rectangle. Opposite sides are parallel and they're equal. Number one, right? You know that. And the interior angles are all right angles, 90 degrees.
Yes.
Yeah, we use those the factors of the shape are important when you are doing an analytical geometry question. Right. And you know, I believe you know how to calculate the gradient of a straight line.
Yes, I do.
Right, good. And you also know how to use the formula at the back of the page.
Yeah.
Right?
Yes.
Great. So we're gonna have a very good time here. Right. 5.1, show that A is equal to 4. Show that A is equal to 4. So A is the y coordinate of Q. So Q is
Of Q,
the
yes.
4 and what? And A.
Yes.
Right. So what we are going to use there, we are going to calculate the gradient of those two lines.
Okay.
Right. We will calculate the gradient of we will calculate the gradient of PQ. So gradient of PQ is increase in what? MPQ is increase in Y over increase in X. The formula for gradient at the back, Y2 minus Y1
minus Y1
over
X2 minus X1.
Yes.
X1.
So our Y2 here, when we are calculating for PQ, our Y2 will be A and our X2 will be 4. X1 will be minus 4 and Y1 will be 0.
Yes.
Right. So A minus 0 over what?
Over minus 4 minus 0.
Over 4 minus 4. Remember,
Yes.
the X is the 4 minus 4. To give you what? A minus 0 over 4 plus 4, because a minus followed by a minus is a plus.
It's a positive, yes.
Okay, so let me try to do this to write for you here. Right.
Yeah, because they I'm a bit.
Okay, so if I say gradient of PQ.
Of PQ.
Right. And people call it, and in maths we normally say M, and then
M over
and then we put
equal
subscript.
Yeah.
PQ like that, isn't it?
Oh, okay.
And then we say it is equal to, I insert a fraction, right?
Yeah.
Okay. I will be right. So, and then, so I'm gonna just say the denominators are the x's. So it's 4 minus
4 minus 0.
4 minus 4.
Oh, yeah.
Look at the x coordinates, right? And then the numerator will be A minus
A 4.
A minus 0. The y coordinate.
Hey, oh, sorry. Okay. Yeah.
All right. Let's do this. The important thing. Let's do this P. You do this P. Right. The coordinates is minus 4. Minus 4, 0. You close your bracket, right? And then we put our Q. We put our Q. You close your bracket, it will be what? 4.
It will be 4 into A.
4 and 8, right? Like that. So so whenever we are writing coordinates, we start with X and then Y, right?
Yes.
So this is X.
X1.
Oh, yes, I must put X1, right? I'll just try to be.
It's fine. I already put on the question paper. I'm the one who made a mistake at first.
Okay, so you are sorted now, right? Okay.
Yes.
So now, so this one will just be equal to A over
A
8.
over yes, over 8.
Because 4 minus 4 is 4, A over 4 plus 4, which is A over 8.
Yes.
So this A over 8 is the one that is here. So you mean you are not seeing this now? Because it's going to help
I
us.
am.
You can see now. It's going to help us if
Yeah,
you
I can
can see this, right? So A minus 0 over 4 plus 4. You know where the 4 plus 4 came from, to 8. And then this one is the gradient of QR, the other line that is going down.
Okay.
Again,
Of
the other line.
QR. Okay, all right.
Gradient of the
Yes.
other line. So why are we doing this?
Okay.
Because
So which means
the product of these two gradients must give us -1 because these lines are perpendicular.
yeah.
You know that one? Perpendicular lines, if you multiply their gradients, it is equal to -1.
It's one.
-1. So because of this right angle, this 90 degrees here, this line PQ is perpendicular to QR. So their gradients, if you multiply them, they must give you -1. So we are using that information to solve for A. So now, right, I'm continuing.
Yes.
This to make it easier for us. So it's equal to -1. Then A, this one 4 minus 6 is -2. A times A over is equal to -1. You can see that. Then when you are multiplying, A times A is equal to A squared. Over A times -2 is -16. You know that, which is equal to -1. Then you cross multiply. -16 times -1 gives you +16. And then A squared is equal to 16. So A is equal to the square root. It's plus or minus the square root of 16. So the square root of 16 will be plus or minus 4. Will be plus or minus what? 4. Why? Because if you say -4 times -4, you get your +16. If you also say 4 times 4, you also get your positive.
Negative.
That's why the quadratic formula, you remember, it's -b plus or minus the square root. Whenever you write the square root in front, you must put plus or minus before. Right? So, but now we take A is equal to 4 because our answer has to be greater than 0 because we are talking of a distance. So you can't say the length of a line is you get, and we are in the first quadrant. The value of A is an X value and it must be positive. So you go back, you go back to your graph here. So your A is a positive X. Do you see that? Because it's after the origin. So you can't take -4. The A must be greater than 0. So that's how you take the +4.
4. Okay.
Okay. So that's how we have shown that A is equal to 4. There are other ways of doing it. You can use the Pythagoras theorem to show that A is equal to 4, or you can use the midpoint theorem. But the best one is the one that we did on top, right? These ones I'll send
Yes.
you for you to just look at them, but the best one we've already done it. Then question 5.2. You see question 5.2. Determine the equation of the straight line.
Determine the equation of the straight line passing through the points S and R in the form of y equals to mx plus c.
In the form of y equals to mx plus c. So whenever we see a question that says in the form of y is equal to mx plus c, we know that we are going to use that equation y minus y1 is equal to mx minus x1. That equation at the back, you remember it? Of a straight line. No.
Oh, which one is that?
At the back, on the formulas.
Yeah.
Can I scroll to the formulas now? Look here, I'm going to the formulas.
No, I have.
Oh, you have them?
I have it. Yeah.
Okay, so this area, do you see where my cursor is moving?
Yes.
That's where we have analytical geometry here. So this is the equation I'm talking about, y minus y1 is equal to mx minus x1. So what do you need in this equation? You need one set of coordinates and you need the gradient. M is gradient, y1 and x1 are a set of coordinates. You use that to find the equation of a line. Right, so we go back now. Right, so the equation of a straight line passing through S and R. I'm gonna go back to the diagram to see where S and R. Okay, so S and R, you see this line?
Yes.
SR is parallel to PQ, to the line that we calculated before. You know that?
Yes.
And we said the gradient of PQ is A over 8. You remember that?
Yes.
And we said A is 4.
Yes.
And then 4 over 8 is equal to half.
Yes.
So the gradient of PQ is equal to the gradient of SR. So M is equal to half. M is equal to half. And then your X1 is 6. Your Y1 is 0. You take the set of coordinates where R is. You see, the line is passing through R, and R we are given, it's X1 is 6, and Y1 is 0. You plug into the equation now. If I plug into the equation now, I will say Y minus
0.
Yes.
0
is equal to half.
Is equal to
half open bracket
into
x minus, what is the value of x?
Minus 6.
Minus 6.
6.
Yes. In the form y equals to mx plus c. So your answer will just be equal to y equals, sorry.
Can I ask something?
Yes.
You said it's equal to y, ne?
Yeah.
How about we move the values? We can move the 0 to the right hand side.
That's what we are going to do next. Actually, when you are subtracting 0, any number minus 0 is 0. So you just have y equals half x, half open bracket x minus 6. So you say half x. So you are going to have half x, and then half times minus 6, it will be what? Minus half of 6 is what? 3.
3, yeah.
Yeah. So, okay.
Oh, so half is going to multiply everything
Yes.
because it's outside the brackets.
Yes, we are going to remove the bracket.
Okay.
Okay. There you go. You see it here.
Yes.
So
Yes, I can see it.
the gradient of SR is equal to gradient of PQ because PQ is parallel to SR. And then Y minus all this calculation is right here. So I know it doesn't make sense to just look at the memo, but if I explain to you like this, I hope we are getting somewhere.
Yeah, I had started doing analytical geometry after a long time, but I managed to read through it. I just went on the notes and I read some of the stuff before I started doing the problem. That's why most of the problem, there won't be a problem because I have read most of the angles,
Thank you so much.
what the gradient, yes.
All right. So
Because
now
I have been doing, I think I have 6 years without doing paper 2. So it's quite
we are going to sort paper 2
hectic.
out. So let me just,
Yeah.
okay, that's fine. This session, I wanted you to just see what you are getting yourself into before you pay. Because
Yeah.
understand, people are tricky these days. They take people's money.
Yeah.
So it's
Yeah.
okay for you to pay when you don't know what's going to happen. Right. Right now, calculate the coordinates of S. Calculate the coordinates of S. Again, right, we have got the equation of the line RS. We calculated it on top. It's y equals to half x minus 3. The equation of the line RS. Now we want to calculate the equation of the line. I go to the diagram. The line PS. You see PS. Because the line RS and the line PS, they all meet at S. So S is the common point. So if we equate their equations, they will give us the values of X and the values of Y. And those are the coordinates of S. You get it now? So the equation of SR, we have got it. It's Y is equal to half X minus 3. So we are sorted for the equation of SR. Then the equation of PS, remember again, we are going to take the gradient of QR. The gradient of QR, you remember? It was it was A over
negative.
So let's check again. The gradient of QR was A over negative 2, right? And our A is 4, right?
Yeah.
And 4 divided by negative 2 is a minus 2.
Yes.
Right. So the gradient of PS is minus 2. So I'm going to say Y minus the Y coordinate here is 0 again, so we don't have to write it, but let me just write it for the sake of understanding. Y minus 0 is equal to, now the gradient we agreed it's minus 2. We open bracket X minus, what is the value of X there on P? On P, the coordinates of P, minus 4. X is minus 4. So you put minus 4, which makes it plus 4. Oh,